ladies and gentlemen.
So let's talk triangles. Very broadly, all triangles. So the interior angles of all triangles, no matter what classifications we give them, all of their interior angles sum to 180 degrees. They add to 180 degrees. So let's try a problem that uses that. So if we are given that the interior angles are 10x, 12x minus 2, and 8x plus 2, in order to find out what x is, we're going to add all of these together and set it equal to 180 degrees. So we have 10x plus 12x minus 2 plus 8x plus 2 is equal to 180 degrees. Technically, we would have degree symbols on all of these, so I'm going to drop the degrees for now. We don't need these parentheses because we're not doing any multiplication or division or powers or anything like that, so we can drop these parentheses, and then we can combine our like terms. So we have 10x's plus 12x's plus 8x's. Well, 12 and 8 make 20, and 20 plus 10 is 30x's. Then we have a minus 2, and we have a plus 2. Those would cancel out to be 0, so we're just left with a 30x on the left and 180 on the right. Then we would divide both sides by 30. And we can see that 1 divided by 10 to both, we get 18 over 3, and that is 6. So, not too bad, hopefully. The other thing that applies to all triangles, regardless of their classification, is that the shortest two sides of the triangle must add to be more than the longest side of a triangle. So we call that the triangle inequality. So if you add any two sides together, it must be longer than the third. Otherwise, you have a straight line if they're equal, or you just have two ends that don't meet up. So let me give you an example. So if I have three sides here, and we are saying that this is 2, this is 5, and this is 7, the only way that's going to work is if the 2 and the 5 literally lie on top of the 7, then you have no area inside, so it's not a triangle. Otherwise, if you have 2 and 4 and a third side of 7, they're not even going to touch. So the smallest two sides have to add to be larger than the largest side. And that works for any way you arrange it. So technically, like the 5 and the 7 have to be larger than 2, 4 and the 7 have to be larger than 2, kind of thing. It has to work all the different ways. But the major way to think about it is the smallest two sides, when you add them together, must be larger than the largest side. So just keep that in mind. So if we have a question like we have here, where we have a triangle and two side lengths are 9 and 14, what is a possible side length for the third side? Well, 9 plus 4 is equal to 13. So the largest it could be is 13. So the largest it could be would be 13. Now, what's the smallest it could be? Well, 9 is the largest number we're given. So something plus 4 has to be greater than 9. And that means that something has to be greater than 5. So the largest it could be is less than 13. I should put a less than there. And the smallest it could be would be greater than 5. So any number less than 13 and greater than 5 would work. So basically, we can pick any x we want to as long as 5 is the smallest and 13 is the largest, non-inclusive. We can't use those. If we use 5, it's a straight line. If we use 13, it's also a straight line. So we could use 7, 6, 12, 12.9, like 5.1. We can use anything we want as long as it fits that specification right there. So hopefully not too bad. Again, for any triangle, you're going to have these properties. Interior angles sum to 180, and that the two smallest sides must be larger as a sum than the third side. If you have any questions, please let me know. Otherwise, I look forward to seeing you in the next video.